Today, class, we're going to learn about polygon sum conjectures. Polygon sums. Polygon sums. And so if we do, I'm going to try one more time to make a triangle and see if it works. We'll make a triangle. Okay, well, let's pretend that this is a triangle. If this were a triangle, if I have three sides, how many degrees do I have sum of angles? What's the sum of the angles? That's 180, right? If I have a four-sided figure, like a quadrilateral, and it's not going to let me, my tool over there doesn't work, so I'm going to just try to draw with straight lines. So if I were going to draw a quadrilateral, any old quadrilateral with four sides. So four sides. How many degrees do those four sides add up to? Does anyone know?
160.
How much? Don't shout out. Raise your hand. Maddie, Jay, 360. Do you know why it adds up to 360?
It's got four sides.
Okay, watch. Okay. Well, it does add up to 360. We'll talk about
Is
it.
it 90 times 4?
Oh, that's one way to think about it. Okay.
That's
90 times 4.
Does 90
But then this isn't 90 times 3,
That would be
right?
60 times 3.
Oh, if they were all the same. Yeah, kind of the right idea. If I had five sides, let's see if it will let me draw a five-sided shape. Five sides. Here's a five-sided shape. Five-sided shape, I said. The pentagon. Is this going to let me draw a pentagon? It is. Okay. Five sides. How many different, what do you think the sum of the angles is?
540.
How do you know that, John? That's correct. That's 540. Where did you get that
Vince
from?
Carter did that in the NBA dunk contest.
What?
540 dunk.
You did it what's that, where you spin around?
Yeah, one time and like a half.
Ah! Okay, so, hey, that's the way to think about it, right? Because if this is one spin, right? This is how much of a spin? Half of a spin, right? This is one spin, this is 1.5 spins, right? So if I had a six-sided figure, that's six-sided figure, like a hexagon, how much would you expect those angles to add up to?
720.
Six sides, it would be two spins, or 720. Now, that's one way to think about it. Another way to think about it is if I were to cut these shapes up into triangles, right? Watch. If I go like that, how many triangles do I have? 2, right? How much do these angles, how much does angle 1 plus angle 2 plus angle 3 have to add up to?
180.
How much is angle 4 plus angle 5 plus angle 6 have to add up to? 180. So altogether, how many degrees do I have? 360. You see? That's where that kind of comes from. So if I were to do the same thing, like starting at one vertex and seeing how many different triangles I have, right? How many triangles do I have there? 3, and this one has 180 degrees. This one has 180 degrees. This one has 180 degrees. 3 times 180 equals 540 degrees, right? And how many triangles could I make here? 4, not 6. 1, 2. From one vertex, right? I can make 4 triangles, right? And so I have 180 plus 180 plus 180 plus 180, or 720 degrees. Anyone think of a formula that I could use to find the sum of the angles of a polygon?
Oh wait, I think you wrote this down. Oh, just these.
Yes? Who said that? Sarah.
N minus 2 times.
Did you just come up with that on your own?
Yeah.
Very good. Okay. Sum of angles of a polygon, okay, is equal to n minus 2 times 180. Right? Because here I have 4 sides, you have 2 triangles. Right? So the number of triangles is 2 less than the number of sides. So n minus, so you should write that on your conjecture sheet. That would be, my numbers are going to be off because this is from last year, but it still works. Polygon C32, okay? The polygon sum conjecture, the sum of the measures of the n interior angles of an n-gon is n minus 2 times 180. Interior means they're talking about these angles, the inside angles here, right? And not the exterior angles. We'll talk about the exterior angles more on Monday. All right? So n minus 2 times 180. 5 minus 2 is 3 times 180 gives you 540. So, and then for a pentagon, the conjecture before that, these are just kind of learning how to get there, okay? But what's the sum of the angles in a pentagon? 540. So you could just write that in the C. What's the one before that? What's the conjecture before that?
C31.
C31. And the conjecture before that talks about a quadrilateral, and that would just be 360, right? So 360. And so for anything, so if they said something like find the sum of the interior. Don't worry, I'm not going to teach you that much more stuff. Interior angles, just a little more. Angles of a heptagon.
Is the sum or conjecture sheet?
No, this is just an example. Find the sum of the interior angles of a heptagon. What's a heptagon? How many sides? 7.
7 minus 2 times 180.
Very good. 7 minus 2
So 5
times 180, which is 5 times 180. What's that? 900 degrees?
Yeah.
900 degrees.
That's really, wow. Who thought of that equation in
Who?
this class? Who said n minus 2?
Sarah.
Good job.
Good job. Okay. And she's good at soccer too,
Oh, nice.
from what I heard. All right.
What position do you
Okay.
play?
So, what if they said, okay, what if they
It's
said,
the man in the center.
fine,
George got it.
exterior, we're not there. But say they said something, whoops, I don't want that tool.
She said center
Well,
man.
let's make a regular hexagon. What if I said find the measure of each angle?
So do we literally use our protractor?
No, no protractor. In a regular hexagon. So, in this case, who can tell me how I do that? Go ahead, Sophia. You don't have to go through all that. Hey, stop all the chatter. Maybe you should take some notes, guys.
Look at these notes.
Got it.
Yeah, I got notes.
Let me see.
What's the sum?
Would you find the
The
sum?
sum is
720
so you just divide by 6.
divided by 6, right? So the sum is 720 divided by 6. What does that mean? 120 degrees apiece, okay? See that? 120, 120, 120, 120, right?
What if they weren't all the same?
Yeah.
Well, that regular means that all the sides and all the angles are the same. That's what regular means, okay? So that's congruent to that, etc. Right?
What if it's not regular?
Then you'd have to do something else, right? Hey,
They sorted it last year.
Okay? Then I'm going to draw a couple picture ones. So, what if I said, if each angle in a regular polygon, regular means all the sides and angles are the same, okay? Measures 108. How many sides does it have?
Well, what? So would you like backtrack, like, if a right, so you do 108, then, so that'd be like n minus 2 times 180 equals 108, basically?
Almost, okay?
Oh, that's right.
What you'd want to do is n minus 2 times 180 divided by n equals 108, okay?
Why?
Because that's the number, so this is the sum of the angles. This is how many sides it has, right? And if all of them are the same, then I could just divide by the number of sides, right? So this formula, by the way, this is for the each angle. I don't really have one like this on your conjecture sheet, but it's a good one to know. Each angle in a regular polygon. So meaning if all the angles and all the sides are the same, then I could use this formula for finding each angle. So how do I solve that formula?
Plug in numbers.
No, you don't do
times
guess and check. You
times each side by
You
one.
multiply each side by what?
By
N, right? You want to get rid of the n? So I'm going to multiply this side by n. I'm going to multiply this side by n.
Distribute the worst.
When I do that, I get n minus 2 times 180 equals 108 n, right? I could, you know what? Yeah, let's just distribute. So I get 180n minus 360 equals 108n.
Then wait, why?
This isn't going to work.
No, that's not gonna work.
180 times.
N minus 2 times 108. That's right. I get, now what? No, I don't divide by 108.
Subtract 360 each side.
Okay, I'll add 360 to both sides. Add 360 at the same time. Since I'm lazy, I'm going to subtract 108n from each side.
Why just?
Okay? When I do that, this goes away. I get 72n, right? Equals what?
360.
Equals 360. What's n got to be?
72 over 360.
What is 72 over 360? Don't those both reduce? 9 goes in there 40 times. 9 goes in there 8 times.
Right, 0.2.
Oh,
Oh, 360 over 72.
So much work.
is that right?
5.
5? Did I do that
So
right?
it's a,
Yeah. 5 sides.
Pentagon.
Pentagon.
We have to go through all that work just to find a pendulum.
Well, is there another way to do it? I'm just trying to think, is there an easier algebraic way to do it? You can kind of use,
Guess.
I will show you an easier way tomorrow, but this formula does work. Okay? Yes, ma'am.
when you did under n minus 2 times 180 in the purple, when you did 180 n minus 360.
When I did 180n,
Or use 20 times
It's
2.
in purple, it's like the second purple one.
Because you distribute the
I distributed.
The 180.
N times 180 is 180n, minus 2 times 180 is minus 360.
Okay, thank you.
Okay? And 108n. So 5 sides. 5 sides. Okay, what if I saw a picture? Okay, here's another problem. I'm just giving you kind of some things that you might see. What if I saw a picture that looked, and you will in your homework see a picture that looks like this. Where's my tool? There. So what if I saw a picture that looked like this, and then they extend these sides? I don't want to do those solid. So what if I did this and I told you that this is a regular polygon here? All of these are congruent, and these are congruent, and I want you to find this angle here. And you say, find x. And you say, that's impossible, they don't give me any measurements. Could I do that?
Oh, yes, you
So
can.
it's a regular hexagon,
Hexagon.
and you just have to add up the sides and then n minus 2 180.
Alright, so, good. So it's a hexagon, so how much does a hexagon add up to?
No, 720.
720, right? And if I divide that by 6, we already did this, each angle is 120 degrees, right?
Wait, but,
So, what?
oh, never mind.
Okay, so if this is 120, what does this have to be?
60.
60. If this is 60, what does x have to be?
60.
60 degrees. Okay, is that hard?
No.
Okay, easy. So that's the kind of stuff you're going to see. Let me see if there's one more example, or is it? I think, hey!
Did you grade our test yet?
No. One more kind of problem. So say I had a polygon. Let's see if the polygon tool got to working yet. Does it work yet? Still doesn't work. Okay. Let's pretend that this is a polygon, and I'm told this and this, and this is 80 degrees. Could you find this angle right here?
Yes.
I don't even have to do that, do I? Okay. All right, so we're done. So I'm done talking now. You are going to start working on your homework.